All right, let's look at the radius and interval of convergence of a power series. All right, so let's dive right into this example. All right, so we have a summation and it goes from 1 to infinity. Then it's negative 1 to the n times quantity x minus 1 to the n over n times 2 to the n. All right, so what we're going to do is we're going to apply a ratio test here. All right, so ratio test. All right, so you can think of this guy. So this given expression. So this is going to be our an, right? Then we would have to do an plus 1 over an. So if you were to find an plus 1, all you have to do is replace all the n with n plus 1. So you have a negative 1 to the n plus 1, and you have a quantity x minus 1, raise it to the n plus 1 over n plus 1 and 2 to the n. Right? So let's look at the ratio here. So you have a limit as n approaches infinity, and the absolute value of an plus 1 over an. Right? So let's put the expression in. So you have a limit as n approaches infinity. Then we have an absolute value here, right? So I'm going to put an plus 1, so which is just the expression here. So you have a negative 1 to the n plus 1, quantity x minus 1 to the n plus 1 power over quantity n plus 1. Then you have a 2 to the, oh actually I messed it up, so this is n plus 1 here, right? So 2 to the n plus 1, right? Then we're going to have to divide by an, so I'm going to just multiply by its reciprocal, right? So we have, since we have n times 2 to the n on the bottom, so we have to put it on top since we're taking a reciprocal there. Right, then on top you had negative 1 to the n and quantity x minus 1 to the n. All right, let's simplify. All right, so first thing you can do is since we are taking the absolute value, we can actually just get rid of negative 1 to the n plus 1 and negative 1 to the n, because the only thing they do is they just change sign. All right, so we can just get rid of that. And then we can cancel. Here you have x minus 1 to the n plus 1. You have x minus 1 to the n. So we can cancel n of those. So I'm going to actually just scratch that out so that I know that there's x minus 1 left over there. All right, and also you have a 2 to the n. Cancel with the 2 to the n plus 1. So I'm going to just scratch out the power so that I know that there's extra 2 left over on the bottom. All right, so what you get is going to be, let's see, this is going to be equal to, all right, so let's see, there's some things are just constant. For example, here 2 is a constant. And also x minus 1 is a constant because it has nothing to do with n. So we can just pull those guys out. So we have an absolute value of x minus 1, right, over 2. Then we have a limit as n approaches infinity, right? Then what else do we have? So we have n plus 1 on the bottom, and we still have n on top. So we just need to do n over n plus 1. Right? And we don't really need the absolute value here because nothing is really negative there. Alright, then we can take the limit. So to do that, I'm going to just simply divide top and bottom by n. Alright, that way we're going to get, so this is just a constant, absolute value of x minus 1 over 2. And then we take the limit as n approaches infinity. Right, n divided by n is 1 on top. Right, n divided by n is 1 plus 1 divided by n is 1 over n. Right, as n approaches infinity, we know that 1 over n approaches 0. So what you get is, this is going to be just 1. So you have the absolute value of x minus 1 over 2. Right? Since this is a ratio test, we want to make sure that this is strictly less than 1. Right? Then I'm going to try to isolate the absolute value of x minus 1. So I'm going to multiply by 2. Multiply both sides by 2. We get the absolute value of x minus 1 is less than 2. Right? So make sure that there's no, the coefficient in front of x is going to be 1. Then the radius of convergence is this guy right here. So this is the radius of convergence. Right? So maybe I'll box that out. So we have a radius of convergence there. Alright. Alright, then interval of convergence is can be found from here. We're going to have to, let's see, so we have to write it as interval, let's see, here. Alright, we're going to have to write it as inequality here. So by getting rid of the absolute value sign, we know that x minus 1 is going to be, right, absolute value is less than 2, means that it's going to be between negative 2 and the positive 2, right? Then in order to isolate x, we can just simply add 1 to everyone. So negative 2 plus 1 is negative 1. And we have x. And 2 plus 1 is 3. Right? So x is going to be between negative 1 and 3. And the last thing we need to do is we have to check the both endpoints. So when x is exactly equal to negative 1 and x is exactly equal to negative 3. So let's check endpoints. So I'm going to probably do it here. And points. Right? So let's do x equals negative 1. So what happens to the series if x is equal to negative 1? Right? So what we have to do is plug negative 1 here. So you have summation. Right? N goes from 1 to infinity. Right? So you have a negative 1 to the n. And if you plug in negative 1, so you have a negative 2 to the n and over and n times 2 to the n. Right? And you can see that this guy right here, we can just split it into negative 1 to the n and also 2 to the n. Right? So we can do a cancellation here. So 2 to the n on the bottom and a 2 to the n on top cancel out. And you have a negative 1 to the n times negative 1 to the n is going to be equal to 1 because you're going to have negative 1 to the 2n. So it's going to be 1. So I'm going to just sketch those out. Then what you get is going to be summation. N goes from 1 to infinity and 1 over n. Right? So you can see that this guy is going to diverge because this is a harmonic series. Right? So we are not going to include x equals -1 because the series is going to diverge. All right, so how about the other point, x equals 3? So x equals 3 is the other endpoint. All right, so let's do that. So if you plug in +3, we're going to get summation. N goes from 1 to infinity. All right, so you have a -1 to the n, and 3 minus 1 is 2, so you have a 2 to the n over n times 2 to the n. All right, so we can again cancel 2 to the n and 2 to the n, and what you get is summation. N goes from 1 to infinity, and -1 to the n over n. All right, but you can see that this guy is going to converge because this is going to be an alternating harmonic series. All right, so we would want to include x equals 3. All right, so therefore, if you're looking for the interval of convergence, is going to be, so as we said, -1 is not included, so I'm going to use a -1 with the left parenthesis so that it indicates that we're excluding -1, and the 3 is included because you get a convergence at the x equals 3, so we put the square bracket to indicate that it's included. All right, so I'm going to just box that out. Right, so this is the interval convergence, and the radius of convergence is equal to 2. All right, that's it. I hope that this was clear.